Hecker visited Russia's secret cities in the chaotic years after the fall of the Soviet Union.
When I saw their practice of how they did the protection, the control, and the accounting of the nuclear material, I was terribly concerned.
Hecker says the controls have gotten better, but Krasnoyarsk 26 was the last of 13 reactors that once turned out weapons-grade plutonium for the Soviet Union. The nightmare scenario of a terrorist group like Al-Qaeda getting its hands on a 10-pound chunk and turning it into a weapon still remain.
Imagine one mistake triggering a chain reaction that changes everything. Russia alone has documented 14 criticality incidents, moments where plutonium handling spiraled out of control, unleashing radiation exposure and chaos in facilities designed to be safe. And the damage doesn't stop when the alarm bells go silent. After major nuclear disasters, over 11% of evacuees report ongoing psychological distress, proof that the fallout isn't just measured in rads. Plutonium-238 has kept spacecraft alive in the frozen dark for decades. It powered the Mars rovers, the Apollo lunar surface experiments, missions where solar panels fail and batteries freeze. And it gets stranger. Researchers once implanted plutonium-powered pacemakers directly into human hearts until radiation concerns and costs made lithium batteries the safer bet. The same element that can sit millimeters from a heartbeat also sits behind vault doors in reactor facilities, waiting for one procedural mistake to prove how fragile control really is. Let's walk through what happened at a civilian nuclear fuel facility in Russia. A researcher violated safety protocols. Simple human error, but the consequences weren't simple. The plutonium assembly, stored in a vault specifically engineered to prevent accidents, went critical anyway. Within seconds, radiation flooded the space. Command systems struggled to coordinate. The very scenario that redundant safety systems were built to prevent unfolded in real time. And this wasn't an isolated incident. It was one of 14 documented times that critically spiraled beyond control in Russian facilities alone.
American television cameras had never been allowed to see what went on here deep inside a mountain. The making of enough plutonium for 100 nuclear weapons a year. Now Krasnoyarsk 26 is going out of business. The reactor that produced the plutonium, the last one in Russia, is shutting down.
But radiation exposure isn't where the damage ends. After Fukushima, researchers surveyed over 16,000 evacuees. What they found reveals a crisis most people overlook. About 11.3% reported significant psychological distress, alongside PTSD symptoms and chronic sleep problems. Evacuation isn't just loading families onto buses, it's a mental health emergency that can persist for years, shaping entire communities. Picture this. Split your screen. On the left, a spacecraft warmed by plutonium-238, gliding past Saturn's rings, powered by an element stable enough to work for decades in the void. On the right, a fuel fabrication lab, where a criticality alarm screams, where one violated rule just unleashed uncontrolled fission. Same element, wildly different outcomes. Remember, plutonium once powered pacemakers before being pulled over radiation concerns. The line between invaluable tool and unacceptable hazard is thinner than most people realize. So what does genuinely safer plutonium use look like? Start with the evacuee data. Mental health support can't be an afterthought bolted onto emergency plans. It has to be integrated from day one. On the technical side, those 14 criticality accidents share a pattern. Rule violations. Humans under pressure make mistakes. So facilities need to design procedures that are hard to bypass and easy to audit. Systems that assume error and compensate for it. Which brings us to the question policymakers and the public should be asking. When is plutonium worth the risk? Clear benefits exist in niche, mission-critical contexts. Spacecraft venturing where sunlight dies, where no other power source lasts long enough. But criticality accidents teach us that mishandling risk never reaches zero. Oversight must design for human error, not hope it away. And when disasters happen, evacuation triggers psychological fallout that's measurable, persistent, and devastating. Response plans need dedicated mental health funding and staff, not vague promises. Plutonium's story is power and peril fused into one element, worth harnessing only where its strengths are genuinely unmatched and its risks fully accounted for, not just on spreadsheets, but in the lives of people who'll evacuate if something goes wrong. Rigorous engineering and human-centered planning don't eliminate danger, but they reduce the odds that one critical moment scars a generation. The most dangerous power source isn't locked in a vault. It's in the choices we make around it. If this shifted how you see nuclear risk, or made you think harder about what safe enough really means, drop a comment and subscribe, because we're not done asking the hard questions technology leaves behind.